This video will be on how to isolate variables. So we will be using a lot of equations in this class, and it's important that you understand how to isolate for the variable that you will be solving. You should always make sure that the variable that you are solving for is in the numerator. And I would advise, until you are very comfortable with this, to rearrange the variables first and then plug in the numbers. So there are different ways to do this. First example is where I just have addition and subtraction. So remember that when you're isolating, this is algebra, you just do the reverse operation. So I have delta G is equal to delta H minus T delta S. You don't have to know what these stand for in order to understand how to do this. What is the delta H? If delta G is 600 joules, temperature is 30 degrees Celsius, and delta S is 40 joules per degree Celsius. So I'm trying to solve for delta H. That needs to be by itself. So I have to get rid of the minus T delta S that is on this side. Because I'm doing subtraction, I have to do the opposite operation, and I have to do it to both sides. So I'm going to add T delta S to both sides, and I'm going to end up with delta G is equal to T delta S is equal to delta H. Delta G plus T delta S is equal to delta H. Now I can plug in the numbers. So delta G is 600, T is 30, delta S is 40, and I know that once I've set up my equation, I can just plug in the numbers, and I got delta H, and my value is going to be in joules. So I just add the values and solve. At this point, I will not require you to show your units, because if you're following this methodology, you will end up with the correct units that you're supposed to end up with. The second example is where I have multiplication and division, but there's no fractions involved. So an example would be PV equals nRT is my equation. I need to solve for N if my P is equal to 3 atmospheres, volume is equal to 6 liters, R is equal to 0.0821 liter atmospheres over moles Kelvin, and T is equal to 400 Kelvin. Again, you don't have to understand what these mean in order to do the operations. So I'm trying to isolate for N. So I need to get rid of it. It's multiplied by R and T. Remember that if I just saying nRT, I'm multiplying those numbers. So in order to get rid of them, I need to divide both sides by R and T. So I'm dividing both sides by R and T, and I get N is equal to PV over RT. Now I can just plug in the numbers. P is 3 atmospheres, V is 6 liters, R is 0.0821, and T is 400. And at this point, I can start to look for things that I can cross out. I can reduce 6 over 400 to 3 over 200, and then I plug and chug. So just a reminder of PEMDAS rules. The way that you would put this in your calculator, you would say 3 times 3 divided by 0.0821 divided by 200, or 3 times 3 divided by the in parentheses quantity, 0.0821 times 200. So you've got to remember PEMDAS. And when you do that, you're going to end up with 0.548, and the units would be moles. Example 3, I have fractions, and the variable that I'm looking for is in the numerator. So an example would be P1 over T1 is equal to P2 over T2. And I want to solve for P2 if P1 is equal to 3 atmospheres, T1 is equal to 270 Kelvin, and T2 is equal to 300 Kelvin. So if I have a fraction, that means I'm dividing. I'm dividing P2 by T2, so I have to multiply both sides by T2. And so I get P1 times T2 over T1 is equal to P2. Now I just add in the numbers. 3 here, 300 is T2. It's really important to keep track of which T's you're putting in. And then T1 is 270. And this is a wonderful place that I can cancel out. So 300 and 270 reduced to 10 over 9, and 3 goes into 9 3 times. So it's 10 over 3, or 3.3 atmospheres. And then finally, I have an example in which I have a fraction, but the variable that I'm looking for is in the denominator. So P1 times V1 over T1 is equal to P2 times V2 over T2, and I'm trying to solve for T2 if these are the variables and these are the known quantities that I have. So T2, you'll notice, is in the numerator. So one thing that's easy to do is to just flip both fractions, right? So I can put it into, so remember that something like 4/3 is equal to 8/6, I can say 3/4 is equal to 6/8. So if I flip the fractions, my quantities are still equal. They're not equal to each other the way they were, but they're still equal to one another across the sign. So I flip both sides, and now my T2 is in the numerator, and I can then isolate by multiplying both sides by P2 times V2. I get T1 times P2 times V2 is equal to P1 divided by P1 divided by V1 is equal to T2, and now I just plug in the numbers. 200 for T1, P2 is equal to 6 atmospheres, V2 is equal to 5 liters, P1 is equal to 3 atmospheres, and V1 is equal to 15 liters. I can then reduce, and I get 5 divided by 15 is equal to 1/3, 6/3 is equal to 2/1, and then I get 400 thirds, or 133.3 K.